Hello and welcome everyone. Thank you for joining us for today's webinar. My name is Muzamil and I'm heading marketing at Zscaler South Asia region. This is our fourth session of Z Talk Live and is a recurring webinar which we are hosting every Thursday, same time. Topic of today's webinar is leveraging source IP anchoring to enforce Microsoft conditional access. In this session, we will learn how our customers can now anchor their authentication traffic to a unique source IP address and allowing them to leverage IP-based conditional access policies for Office 365 and other applications. A little housekeeping items before we get started. If you have any questions during the presentation, please type them into the question panel and we will bring them at the end of the presentation. Now, without further delay, I'll turn the time over to presenter. Our presenter today is Mr. Manish Jaisal, Senior Product Manager, Zscaler. Over to you, Manish.
Thank you, Muzamil. Hello, everyone. Good morning, good afternoon, good evening. The topic we're going to cover today is how we can leverage source IP anchoring to enforce Microsoft conditional access rules. Let me start by setting the agenda for today's session. So we're going to cover a lot of technologies today. So I'll take the first few minutes to just cover the different technologies that work together to make this work. So we'll talk about Zscaler Internet Access briefly, Zscaler Private Access, then we'll talk about Microsoft Azure AD and Microsoft Conditional Access, and then we'll really talk about the problem that we are trying to solve here, which is source IP-based authentication. And then we'll spend time talking about the solution and how that solution can be used to leverage source IP anchoring with conditional access. And finally, I'll give you a small demo of how things are configured on ZIA and ZPA and how conditional access can be leveraged. So let's get started. Let's talk about the technologies involved. First, let's talk about the Zscaler platform itself. Now, I won't get into a full-blown description of Zscaler, as that might be a whole session in itself. I'll cover what our platform does enough so that we have context of the problem that we're trying to solve here. So Zscaler is a cloud-based security platform. And we have two major components, Zscaler Internet Access. This is the part that secures all your internet traffic. So your workforce would access all the external applications through Zscaler Internet Access. And we make sure that none of the threats get in and none of the secure data gets out. So it's a platform that gives you full data leakage protection, threat protection, and so on. On the other hand, a Zscaler Private Access is our other offering, which is leveraged to access internal applications. So these are applications that are not exposed to the internet, sitting somewhere in your data center or Azure or AWS or maybe some office location. And you want a secure way of accessing these applications, that's where ZPA comes into the picture. So using these two products, we are able to give you full security access to applications that are on the internet, as well as internal applications hosted in your environment. Now, let's get a little deeper into Zscaler Internet Access and how we are achieving this. So basically on the Zscaler Internet Access side, we've got multiple data centers all across the globe. And your users would either be mobile users working from their homes or office locations or your headquarters. And the first destination they would be reaching out to is one of our Zscaler data centers. Which would possibly be located very close to your office location. And then from that point, they will reach out to a destination on the internet. So like Salesforce, Workday, LinkedIn, whatever it might be. So all traffic goes through the Zscaler Internet Access platform, and we have full visibility into all your traffic. So using that, what we are able to do is provide you full inline security. So cloud sandbox, DNS security, data protection, policy enforcement, like legal liability websites should not be allowed, and so on. So that is what the Zscaler Internet Access Platform is able to achieve using this architecture. And there's a lot more that we can talk about, but I think this is enough to set the background for the problem that we are trying to solve using source IP anchoring. So that's Zscaler Internet Access. Now let me move into Zscaler Private Access. Zscaler Private Access is, as I mentioned before, it's a platform that allows you to access internal applications that are not exposed to the internet. So these applications might be sitting in the Azure cloud, AWS, or your own data centers. Um, and the idea is that you would have a client connector, which is a small, lightweight application running on your user's laptop, which talks to the Zscaler Private Access Cloud. So that there's a secure tunnel communication between the client connector and the ZPA cloud. And then there is another component called app connector, which is a lightweight virtual machine that sits right next to your applications. So it has line of sight to your applications. And this cloud connector, this app connector connects to the ZPA cloud as well. So now you have two independent channels, one talking from where the app is located, one talking from where the client is located, and then the cloud makes sure that these clients are able to talk to these applications. But the way we do it is we make sure that it follows the principles of zero trust network access. So when a user tries to access an application, the first thing we do is we look at the policies, determine if this application should be accessible or not. And based on that, we allow the user to access the application. If the user is allowed, then these two micro tunnels, they are joined together. And what ends up happening is that the employee is able to securely access the application located behind one of these locations. So that is a gist of how Zscaler Private Access works. Crucial thing to know is that there are three independent components that work together to make it work. One is the client connector, which resides on the employee's computer. One is the app connector, which resides in the data center or the cloud where your application is located. And the third is the ZPA service edge, or what we call the broker, which is located in the cloud, which acts as the communication point between these two independent components. That sets the background about Zscaler Private Access. So those are our two main products that work together to make source IP anchoring work. I'll come to that, but before that, let's talk about the Microsoft components involved. So on the Microsoft side, we're talking about Microsoft Azure AD. Now Azure AD is pretty popular, so I don't think I need to give an introduction about Microsoft Azure AD. It's basically a cloud-based identity platform. Think of it as an authentication layer for all your applications. You have Office 365 applications and all other applications, including Zscaler, that can leverage Azure Active Directory as the authentication front end. So anytime a new user tries to access our platform, we can redirect the user to Azure Active Directory, where the user can authenticate themselves. And once the user is authenticated, the user can go back to our service. And now we have the context of the user, and based on the context, we can apply or we can allow or deny the user. Um, so that's Azure Active Directory. And the second component is Azure Active Directory conditional access. And this is the piece that we're going to talk about in a little more detail today. Uh, think of Azure AD conditional access as another layer above Azure Active Directory authentication. So the job of authentication is to identify whether a user is an authentic user or not, or whether the user is really who the user claims to be or not. Conditional access, uh, as the name suggests, adds additional layers of conditions based on which you can decide whether you want to allow access or not. In the Microsoft world, these additional conditions are called signals. So if I have to think of an example, a user comes in, tries to access, let's say, Outlook, and the first thing you do is you authenticate the user. You ask them to put in their username and password. Once that is done, then you look for these additional signals, like whether he's coming from a recognized device, a corporate device or not. Is there a risk? Is he coming from a country that you don't trust? Or is he accessing an application that he should have access to? And then also rules specific to certain users or certain IP locations. And then based on all these signals, you can take a decision whether you want to allow access, you want to block access, whether you want to prompt for multi-factor authentication. And based on these rules, you can either allow them access to apps or not. So that is a view of what conditional access does. And what we're going to talk about today is location-based conditional access. So what location-based conditional access basically means is that it's a way to leverage the source IP address to make conditional access decisions. And this is an example of what it's capable of doing. So if you see traffic coming from a known source IP address, and by known source IP address, I mean a customer owned IP address that they can then add to the platform saying that x.x.x.x is my known IP address. Always trust this IP address. So if anything is coming from a known source IP address, you allow access. And if it's coming from an unknown source IP address, then you block access, or optionally you can prompt them for multi-factor authentication. So the typical use case for using something like this would be if you have an organization that doesn't want users to access their emails from home for security reasons. What you can say is that Outlook would only open up if you're coming from known source IP addresses. So what that means is that when they try to authenticate into Outlook, if they're coming from a known source IP address, one of the office location IP addresses, then the access would be allowed. If they're sitting in Starbucks or sitting at home, it's an unknown source IP address, then you would just block access. Or if you don't want to block access, you just want to make sure the user is actually an authenticated user, or a user belonging to the organization, you can do multi-factor authentication where you can have like a second factor based on text, SMS, or email or whatever. So that's what source IP based conditional access is. And that sets the background for what we're going to talk about today. So those are the four technologies involved. ZIA is involved, ZPA is involved, and Azure AD conditional access is involved. So let's talk about the problem first. What is the problem that we are trying to solve? The problem basically is IP-based authentication and the challenges we have using IP-based authentication with Zscaler. So the whole idea of source IP-based authentication is that the destination server would make authentication decisions based on the public source IP address of the incoming packet. So it would just look at the incoming packet, whatever is the source IP. If it trusts the source IP, then it would be allowed. Otherwise, it would be blocked, as we just talked about. And Microsoft Azure AD conditional access is a very good example of source IP based authentication, but that is not the only one. This is a very commonly found scenario. Okta uses an equivalent of this in location-based authentication policies. Salesforce has its own location-based policies where you can control access to Salesforce based on source IPs. And then if you host internal applications publicly, which are protected by a firewall, then there are chances that you also have firewall rules that only allow traffic from certain known IP addresses, for example, your partner IP addresses. So it is likely that you might be using source IP authentication already in your organization by simply applying inbound firewall rules that only allow traffic from certain source IP addresses. So these are some examples of source IP authentication being used out there. And traditionally, this has always been a problem with Zscaler internet access. And I'll explain why Zscaler internet access and source IP based authentication, they tend to clash with each other. So the crucial thing to understand is Zscaler internet access is based on shared tenant architecture, which basically means that we have a pool of servers called Zscaler service edge nodes, also known as ZENs. And these servers are shared by all our customers. The way our solution works, the traffic comes in, it is load balanced, it ends up on one of the ZENs, and then the ZEN does full inline inspection, full security offerings. And the end result is that if the traffic is allowed, then it is allowed to reach out to the web application, and then the response is sent back to the source. If it's not allowed, then it's just blocked. But the crucial thing to understand is that this server is multi-tenant, which means that the IP address of this server is not owned by a single tenant. It's a public resource owned by Zscaler. So let's look at the how the IP changes in this whole traffic flow. So if we start from the source, I've got a.a.a.a, which is a.a.a.a, which is a symbolic IP address. Let's say this IP address belongs to your branch location. Now, when you reach out to the internet, your traffic goes through Zscaler. So it would reach the load balancer, and from the load balancer, it would end up on one of our ZENs. And the ZEN would do its magic. So it would do full inline security stuff. And then what it finally does is it forwards the traffic to the web application that's located in the cloud or anywhere in the internet. Now, when it does that, it uses the source IP address of the ZEN itself. So the original source IP was a.a.a.a, but you won't see that anymore because the ZEN would forward the traffic as z.z.z.z. So what the web application sees as the original source IP is this IP right here. Now, the original IP address is not visible to the end server on the IP layer. That should be obvious. But it is visible to the original, the original IP address is visible as an XFF header in the HTTP layer. So this is something that mostly all HTTP proxies do. We add an additional X forwarded for header, which has the original source IP, that is a.a.a.a. Um, but not all web applications have the ability to look at the XFF header and determine what the original source IP was. In most cases, they would just look at the layer 3 source IP and take a decision based on that. So that explains the problem here. The problem is that the web application, if it is designed to trust only this IP address, then when the traffic comes from this IP address, then uh, the web application would just black hole the traffic, or say give some template response that I don't trust you. And this has been seen for many different applications, especially government websites. For example, the Indian tax website, it won't be accessible if this IP address belongs to an IP outside India. So that explains what source IP based authentication, the problem that source IP based authentication has with Zscaler Internet Access. So let's move on to the specific case of Azure Active Directory. Now in Azure Active Directory, as we already talked, conditional access rules require visibility to the original source IP address. And as we explained in the previous slide, this original IP address is never visible to this application, because to this application, only this source IP address would be visible, one of these, depending on where the traffic is coming from. So in that case, the customer who's using Azure Active Directory is left with only a few options. One is to trust all these IP addresses, and then not trust anything else. But there's a problem with that. And the problem is that Zscaler IP addresses cannot be trusted by a single organization as their own, because they're shared by multiple customers. So if they want to create a rule that says only people from my office are allowed to access this application, then trusting the Zscaler IP address does not necessarily ensure that, because this IP address can also be seen when another customer is using this Zen. So basically, whenever any customer is going out, they might be able to see, or they would end up using one of these IP addresses as their source IP address. So we already talked about IP location based conditional access rules. We already talked about the use case that these are used when you want to make very specific conditional access rules that want to control the source, that want to control the access based on the location. And the location is determined based on source IPs. And when Zscaler is involved, your original source IP is not retained. It is converted into one of the Zen IPs. So this solution, or rather this conditional access architecture, breaks in this scenario. So that is really the problem that we are trying to solve. So I hope I've explained the problem pretty well. Now let's jump into the solution, how we are trying to solve this problem. Now, the way we are trying to solve this problem is using source IP anchoring. What source IP anchoring does is it creates a logical link between your Zscaler Internet Access cloud and your Zscaler Private Access cloud. So your ZIA tenant and your ZPA tenant, they would be logically linked together. And based on this, what you are able to achieve is that when the traffic reaches one of your ZIA Zens, instead of forwarding the traffic directly to Azure Active Directory, and this is policy based. So you won't do this for all traffic. You would do this for sensitive traffic, like traffic that is destined to Azure Active Directory. You would create a policy that says traffic to this destination needs to be source IP anchored. And what that would basically do is that the Zen won't directly forward that traffic to the internet. It would actually forward that traffic to the ZPA cloud, which basically means that it will forward the traffic to the ZPA Zen. And what the ZPA Zen in turn would do is that it would identify that, okay, this traffic is coming from the ZIA tenant of this customer. So I need to forward this traffic to the ZPA connector of this customer. And what ends up happening is that your traffic went from the ZIA cloud, it went into the ZPA cloud, and now from the ZPA connector, and I'll like to recap here. So this is the app connector. This is a lightweight virtual machine that is hosted either in your data center or in one of the public clouds like Azure, AWS, or Google. And you own this piece. So the IP address of this app connector is also owned by you. And it is fair to assume that you have a way of routing traffic from here directly to the internet. So the idea is that the traffic comes to ZIA. From ZIA, it goes to ZPA. From ZPA, it goes to your individual app connector hosted by you, either in your data center or in one of the public clouds. And from there, it goes out to Azure Active Directory. What ends up happening in this process is that the source IP that the traffic has is an IP that is owned by you. It is not the same IP that the traffic started off with. The source IP was A.A.A.A, but in the end, the IP is going to be B.B.B.B. But that is not a problem because this is still an IP address owned by you. So it is unique to you. You can think of this, just to simplify, you can think of this as natting your original traffic from this IP to this IP and then presenting it to Azure Active Directory. So now that you own this IP, you can go into the Azure Active Directory configuration and say, I own this IP. So whenever you see traffic from this source IP, always trust that traffic. And once you're able to do that, you can apply conditional access rules, because the final objective in applying location-based conditional access rules is to trust a customer-owned IP address. So let's do a recap. I think this slide is the crux of the whole presentation. So the original problem was that this traffic was coming directly from these Zens to Azure Active Directory, which means that it came from one of these IP addresses, and Azure Active Directory doesn't really trust any of these IP addresses because they are not customer owned. Although you can go in and define these IP addresses as trusted IPs, but that won't give you a lot of security because these are multi-tenant IP addresses. They don't really belong to you, so you can't always say that anything that comes from this IP is trusted. In order to solve that problem, we needed a way to make sure that the traffic to Active Directory always comes from a trusted IP. So the way we were able to achieve that is instead of forwarding the traffic directly to the internet, in which case it is bound to take one of these IPs as its source, the traffic is logically linked to the ZPA broker. And from there, it ends up on the app connector, which is a virtual machine hosted by you, and its IP address is owned by you. So the traffic ends up taking this source IP and it goes out to the internet, and when it does that, your source IP authentication is successful. So this is what we are calling source IP anchoring, because you're basically anchoring a certain IP address onto certain traffic. A crucial thing to point here is that this is all policy based. So we are not saying that send all your traffic through this, because that is impractical, and for 99% of your traffic, the source IP doesn't really matter. What matters is that the traffic is secure. It is You may want to make sure that all the security policies are applied. So we can ensure that through our ZIA platform. But for 1% of your traffic, that actually requires that it comes from a certain source IP. In that case, we forward that traffic using this um, solution. And the other crucial thing to note is that this logical link between ZIA and ZPA, this is a proprietary communication protocol. We are not just forwarding this traffic over the filed internet. We have negotiations and communications happening between these ZIA enforcement nodes and ZPA broker. So the broker actually knows each customer, and it knows, okay, this traffic is coming from this known customer, and it basically links your ZIA traffic to your ZPA tenant, and then based on that, it is able to identify that it needs to forward the traffic to your app connector, and then it's able to forward the traffic out to the internet. So the last thing to mention is that this traffic is still going through ZIA. So even though the final destination goes out via a ZPA connector, it still goes through ZIA. So it's still going through full inline inspection, and we can make sure that if anything bad is coming back, Zscaler can still inspect it and make sure that it is blocked. So having covered that, let me get into the demo. So let me quickly show you how things are configured on the Microsoft Azure side. On the Azure side, I basically have a conditional access rule. This one right here, IP-based conditional access. This is the one that I created. And what I am saying in this conditional access rule is that this applies to all users. It applies to one application, which is SharePoint. And the conditional access rule is, it basically says any location excluding these two. So I'll explain what that means in a bit. The final piece is that I'm blocking access. So let me get out of this Zoom by opening this again. Coming to my IP-based conditional access rules again. The rule basically says that it applies to all users. It applies to SharePoint. And for SharePoint, I'm saying that this rule applies to all locations except two locations. And what I'm saying is block access. So this is like a reverse way of granting access, basically by saying that it is blocked for all locations except these two, which basically means that it is allowed for these two locations and everything else is blocked. So that is how this policy is made. And these two IPs are One is the source IP address of my home, and the second one is my connector IP. So my ZPA connector's IP address. And if I go here, I have a screenshot of my virtual machine, which is running on Azure AD. And this is the IP address that I am using as the source IP. So going back here, uh, this IP address is this IP address. Crucial thing to note is that these are the only two IP addresses that are allowed access, which means that Zscaler IP addresses are not allowed access. So if I just go from a Zscaler IP address, it would fail, um, which includes all IP addresses of our data centers. So the only way to make this work is if my traffic ends up coming from this connector IP address. So that is how the conditional access policy is configured here. Now, this is a Firefox browser. On the Firefox browser, I'll just go to ip.zscaler.com to make sure that my traffic is going through ZIA. So as you can see, it says that the traffic is going through Zscaler proxy, this host name, and so on. And this is my home IP address. This is the IP address of the Zscaler enforcement node that I'm coming through. Now, the thing to note is that this IP is not allowed in the conditional access rule. So the only way I can access this traffic through ZIA, the only way I can access SharePoint through ZIA is if I go through source IP anchoring. If I just go through this IP, then it should fail. And let's go to the SharePoint website. Let's see what happens. So I go to the SharePoint website. This application has conditional access rules applied to it. So the first thing that will happen is it will ask me to sign in. So this is your regular authentication happening. And the page opened, so we know that the conditional access policy allowed us to access. Now, we can identify the source using the sign-in logs here. The sign-in logs usually take 4 or 5 minutes to get updated. So in the meanwhile, I'll show you what the configuration looks like on ZIA and ZPA portal. And then we can come back and look at the sign-in log and look at the IP address and confirm that it actually took the connector IP address. So while we're waiting for that, let me show you the configuration. So on the Zscaler private access side, what I'm doing is I have a connector, and this is the starting point. This is my source IP anchoring connector. This is this connector which is hosted in Azure AD, and this has this IP. So what I'm basically achieving is that I am leveraging this IP as an IP for conditional access policies, or for other applications, this can be the trusted source IP that our customers will trust. And that is the first piece. The second piece is in the application segments. I have created an application segment that basically applies to login.microsoftonline.com. And what I'm basically saying is that login.microsoftonline.com, that is so all Azure AD authentication traffic always uses login.microsoftonline.com. So that is the only URL that we need to trust, or That is the only URL that we need to forward to source IP anchoring um, destination. So basically, there's this new option called source IP anchor. We need to enable that. Once we enable that, we define the segment group uh, and we define the application. So the application in this case is login.microsoftonline.com. And that's pretty much it. That's how I define the application. Then apart from that, I define the server group. The server group is again, it basically points to the connector. So the connector that I showed you is mapped to the server group, which is mapped to the application segment. If you're not familiar with ZPA configuration, this might seem like a lot, but for folks familiar with ZPA configuration, this is just regular ZPA configuration flow. What we are finally doing is that we are saying that login.microsoftonline.com is a destination that is reachable via ZPA, and it is source IP anchored. That is basically, this is the new part that we are adding. And once we do this, we've basically completed the ZPA side of configuration. Now, why do we have the source IP anchor option? Because when we do this, this application becomes visible to the ZIA side. And that is what I'll show you now. So on the ZIA side, we have a couple of new fields. So there's one called Zscaler private access right here. So this is where we need to go first. Now this is a logical link between ZPA and ZIA. So now, as I mentioned before, your ZIA and ZPA tenant are now logically linked together. So when you click on add gateway for ZPA, you can actually see this server group that you created here for source IP anchoring will be visible here. And then the application segment will be visible here. So basically what is happening in the background is that your ZIA tenant is talking via APIs to your ZPA tenant, getting information about these application segments, and then using those to fetch this information. And that is the reason why this source IP anchor option is enabled, because when you enable this, it tells ZIA that this is a source IP anchoring segment. So it would show you that segment here. And the end result of this is that you create a policy like this, which is basically a gateway, which means that this is the destination that ZIA needs to forward the traffic to. So this is basically telling ZIA that this is a valid destination in the ZPA side, which you can use to forward your traffic. And then the equivalent of this is a policy that would actually forward the traffic. So this is just the gateway. This is just a endpoint that you want to reach. The other part is the forwarding policy. So that is under policy forwarding control. This is again a new field that we've added. In policy forwarding control, what you'll see is I've got a rule called auth traffic, and what I'm basically saying, this is what it looks like. So I'm basically saying that for any user, any location, any group, whatever, and any source, and this destination. So the destination is the application segment that I created. So this is how it knows that this only applies to login.microsoftonline.com, because that was defined here in the application segment. So it knows that for login.microsoftonline.com, I need to forward the traffic to this ZPA gateway. And here we select forwarding traffic method ZPA. We also have proxy chaining and direct, but we won't talk about that since here we are just talking about ZPA, source IP anchoring. So what this policy is basically doing is, if I go back to my slide, the one that explained everything, this is this logical link. And these policies are basically these policies that are telling the Zen which traffic needs to be forwarded to ZPA. And then this destination is basically the destination policy here. So this gateway is how ZIA talks to ZPA, that this traffic is meant to be forwarded to this ZPA gateway, and that is how the circle is completed. So once this is done, basically ZIA knows that for this traffic, the traffic needs to be forwarded to ZPA, and then ZPA already has configuration, so ZPA knows this traffic needs to be forwarded to a certain connector, and then that connector knows that this traffic needs to go out to the internet. So that is how the whole loop is completed in terms of traffic forwarding. Now, it's been a few minutes, so now we should have the logs updated in sign-in policy, in the sign-ins on Azure. So let's look at this one. Yeah, so this is user one, Office 365 SharePoint Online. It says interrupted because it was prompted for MFA. And look at the source IP address, 23.99.82.90. And I'll go back to my screenshot of the virtual machine, 23.99.82.90. So as you can see, going back, as you can see, this login attempt was visible to Azure Active Directory as sourced from this IP address, which is the IP address of our connector. And just to make sure that this is not the IP address that my computer is sourcing its traffic from, you can see that here. So that is my home IP address. And you can also see that here, that when I normally log into Azure portal, it is not going through Zscaler, so it is taking my home address. But then when I'm going through ZIA, this is my ZIA IP address. So for all, if I just go to whatismyip.com, it's taking long. You can see that this is the same. It's not exactly the same IP because this is the virtual IP, but this IP, 103, 147, 150, 84. Sorry, my bad. This is not a good example because it's actually looking at the XFF instead of the source IP. So it's able to recognize my home IP address. But the point I'm trying to make here is that when the traffic leaves Zscaler for any destination on the internet, it uses this source IP. But then when it goes specifically to Azure Active Directory, then it uses my connector source IP address, which is what we are trying to achieve using source IP anchoring to enforce conditional access. So at this point, I've completed my original content. I'd like to review if there are any questions from the audience. So I'm looking at the questions. There are a lot of questions there. I'll just pick a few ones that I feel would be relevant to everyone. Uh, so I have a question from Ramesh M. Virtual service edge is enough to address this issue, right? Yes, Ramesh, you're right. So before we had source IP anchoring, we actually had virtual service edge, which is like a ZPA Zen that is hosted in your, sorry, not a ZPA Zen, a ZIA Zen that is hosted in your environment. That is also a valid solution, but that required more routing decisions on the client side. So like a pack file that was required to make that decision on the client side. And that did not work um, if you had like a non-pack traffic, if everything was going through Zscaler. In such cases, mm, there was no way to route traffic to virtual service edge. Now using source IP anchoring, we've shifted that decision to the ZIA cloud. So now you can just flatly send all your traffic to ZIA, and then ZIA cloud can make a decision on what traffic needs to be forwarded to the source IP anchored destination. I'm looking at other questions. So there are a lot of them. I don't think I'll be able to cover all of them. We'll take some of these offline, but let me look at the ones that I think might be common for most of the audience. So Sajita has a question. Won't this add additional latency? And does this use multiple connector groups? So yeah, it does add a little additional latency because obviously there is one additional hop, but it is not very significant because uh, the hop from ZIA to ZPA is not very far because these data centers are mostly co-located. So your ZIA ends and ZPA broker, they're sitting in the same data center, usually just 2 or 3 milliseconds away. And then going from there to your connector, if your connector is located in the cloud, then that hop count would also not add a lot of many milliseconds of latency. And the piece to understand is that this is only for your 1% traffic that needs to be IP anchored. We're never proposing that you do this for all your traffic. That is when latency would really matter. But if you just want to redirect your authentication flows, you might notice that instead of 5 milliseconds, it will take 5.2 milliseconds. And you get the additional security benefit of conditional access. So it usually comes out to be a good trade-off. Antonio has a question regarding ZPA license. That's right. You do need a ZPA license to leverage source IP anchoring. If you are a ZIA only customer, I guess our sales team can tell you what the right way of leveraging source IP anchoring is. There's also yes, there's another question regarding the fact that does this work only with ZPA? Yes, this leverages ZPA. The solution that I talked about leverages ZPA. There's also another solution called proxy chaining, but that is beyond the scope of the discussion today, and it's too late to get into that. One thing I should mention, I was reminded this from the questions, that this feature is right now in beta. So if you go to your beta cloud, you might actually be able to leverage this as of today and try it out and give us feedback. It is expected to be in production in another couple of months. Once we've done a good round of beta testing with our customers, we've got all the feedback, we've worked on the feedback, then we'll roll it out into production. So Yashodhan has a question. Source IP anchoring, why traffic is not directly forwarded to ZPA? Why is it going first to ZIA and then logically connected with ZPA? So Yashodhan, this is because you're right. If I have a ZPA client on the client machine, then I can technically forward this through ZPA. But that is not the point. We are not trying to just send traffic through ZPA. What we are doing is we are letting ZIA make the decision of what traffic needs to be anchored. So this would even work if you don't have Zscaler app. Um, if you just have pack forwarding or you have tunnel forwarding, ZIA will look at the traffic and ZIA will then forward the traffic to ZPA. So all the routing decision happens in the ZIA cloud. That is the crucial piece to understand here. Antonia, you have a good point. So Antonia has a point that the customer owned IP addresses will still be masked from original user locations, and it will be replaced by the IP of the connector. That is right. So your Azure AD conditional access policies will not be based on actual user locations. That is right. They'll be based on the IP, the connector IP address. But you can have, if you really want multiple conditional access policies that are different for different locations, you can actually have multiple connectors. And using source IP based routing rules, you can route the traffic to different connectors. And then using the connector source IPs, you can have different rules for each of the locations. So there are a lot more questions that I have not answered, but I see that I've run out of time. So sorry, I can't answer all your questions right now, but let me see if I can find an easy way of getting back to you with answers to your questions. All right, I think we've run out of time. Muzammil, shall we close the session? All right, that's it for today. Thank you for your time, and I hope you all have a good day.